Welcome to the Colaberry AWS workshop video on reward graphs. In this video, we will learn about what a reward graph is and how it is created. Additionally, we will check out reward graph metrics and how to use reward graphs on AWS DeepRacer. In AWS DeepRacer, after you start training the model, you can examine the training metrics of the reward and track completion per episode to determine the training job's performance of your model. On the AWS DeepRacer console, the metrics are displayed in the reward graph. There are three metrics which are displayed on the reward graph. First, the average reward per iteration. Second, progress per episode. And third, average progress per iteration. You can choose to view the reward gain per episode, the average reward per iteration, the progress per episode, the average progress per iteration, or any combination of them using the toggle. The range of rewards is shown on the left side of the graph, and the range of progress, 0 to 100, is on the right hand side. To read the exact value of a training metric, we move the mouse near to the data point on the graph. Next, let us talk about how the reward graph is created. In AWS DeepRacer, leverages Amazon SageMaker to train your model behind the scenes and uses AWS RoboMaker to simulate the model and the agent's interaction with the environment. Next, let us learn about the reward graph metrics. First, the best model line allows you to see which of your model iteration has the highest average progress during the evaluation. The checkpoint for this iteration will be stored. A checkpoint is a snapshot of a model that is captured after each training iteration. Second is our reward. It is primarily on the y-axis shown, and the reward graph is earned during a training iteration. To read the exact value of a reward, we hover our mouse over the data point on the graph. Our third metric is the percentage track completion. It is shown on the secondary y-axis, and it shows you the percentage of the track the agent completed during a training iteration. Now, iteration, which is on the x-axis, is the number of iterations completed during your training job. Our fifth metric is the average reward, and the average reward is what the agent earns during the training iteration. The average is calculated by averaging the reward earned across all episodes in the training iteration. As defined, an episode or run begins at the starting line and ends when the agent completes one loop around the track or at the place where the vehicle left the track or collided with an object. Our sixth metric is the average percentage completion, and this is during the training phase. This is the average percentage of the track completed by the agent in all training episodes in the current training iteration. Our seventh metric is the average percentage completion during evaluation. This is the average percentage of the track completed by the agent in all episodes run during the evaluation period, while SageMaker is updating the model using the current iteration of your model. Now, in our final section of the video, we will learn how to use the reward graph in the AWS DeepRacer. It is essential to use reward graph as a good indicator for, first, the training time of our model, and second, the robustness of our training model. Let's talk about these. How do we determine the training time of our model? A good indicator of when to stop the training of the model can be determined by watching the graph. It has likely converged if the progress per episode continuously maxes out or reaches 100% and the reward levels out. This indicates that we should stop training. This can be seen in the example graph. After about 400 iterations, all the three metrics do not improve significantly. Hence, it would be a good idea to either stop training the model after 600 iterations because none of the metrics are improving anymore. Another reason to stop the model after it achieves 100% track completion is because Continuing training will cause overfitting in the model. An overly trained model won't perform well in a real world or new tracks because it cannot handle even minor variation between the simulated track and the real track. To check for the robustness of a model, typically the reward graph should rise in value initially and then plateau later. When the graph of the metrics are near the previous values after plateauing, it means the model has learned in a well-defined way and would perform consistently on multiple runs during the model testing phase. In case the values tend to fluctuate drastically or never reach a plateau shape, this means that the model either needs more training time or is very volatile, thus requiring either a change in the reward function or tuning of hyperparameters. With this, we have reached the end of this video and learned what a reward graph is and what information we can gain from it. Thank you.